Greetings, fellow friends of Euclid, gentle geniuses of geometry. Today we begin Chapter 4 on congruence, specifically on triangle congruence eventually. And 4-1 begins with the Pythagorean distance formula. You have already seen this year in proficiencies that you have done. And there are some common mistakes that are occurring, so this is a good chance for us to clear some of those mistakes up so that you can pass those proficiencies as soon as possible. Alright, this is the Pythagorean distance formula for use in the coordinate plane graphs that we see for finding distance between 2 points. Alright, for instance, these 2 points, 2, 5 and 6, 7. The ordered pair 2, 5 and the ordered pair 6, 7. Alright, so it might help you to see this. What this subscript means is the x-coordinate of point 1, the y-coordinate of point 1, 6 is the x-coordinate of point 2, y is the x-coordinate of point, 7 is the y-coordinate of point 2, and in this, it would not matter. We could identify this one as point 2 and this one as point 1, and you'll see why as we work through this. But once I've made that identification, I want you to notice a detail that has missed many of you here. You are to match up the x-coordinates together and the y-coordinates together. Some of you are just putting the first point in this set of parentheses here and the second point in this set of parentheses here. We don't want to do that. This is a detail that we have to get cleared up. X-coordinates go together, y-coordinates go together. Alright, so as you can see, we have done that. 6 goes here, 2 goes here. X-coordinates matched up. 7 goes here, 5 goes here. Y-coordinates matched up. Now we continue on doing the math. Once we've done that correctly, our chances of making a mistake decrease. So 6 minus 2 is 4, 7 minus 5 is 2. Now we have the square root of 4 squared plus 2 squared. Simplifying, 4 squared is 16, not 8. I've seen that on some papers. Very easy mistake to make. We just multiply it by 2. No, it's 4 times 4. 2 squared is 4. Alright? 16 plus 4 is 20. Square root of 20. Now, if I find the square root of 20, before I find the square root of 20, let me tell you that some of you on your proficiency are answering it this way. Because there's so many intermediate steps here, each step down the road, people are forgetting to put the square root symbol over it, and so by the time they get to the 20 down here, they've forgotten that this has to be square rooted. Some of you have, on a problem like this, would do everything correctly, but then leave your answer as 20. Got to square root it. Do not make that mistake. So about 4.47. That's the Pythagorean distance formula. Here you notice we didn't see anything graphed at all. But you might be interested in seeing that, and they have a presentation of this in the book, in the lesson. Here's a right triangle in the graph, and it is in quadrant 1 of the graph. And the points, the ordered pair that identify the vertices of the triangle have been identified. So if I want to find the length of AC right here, I use the x and y coordinates, and you can see we've got x, and it doesn't matter. I call that x1, y1, x2, y2. Actually, I think I did it the other way around, but the main point is that you match your x's together and your y's together to begin with. Alright, 2 minus 2 is 0, 10 minus 2 is 8. So, simplifying, you get 0 squared plus 8 squared is 64. 0 squared is 0, so square root of 64 is 8. So we know that AC equals 8. Alright, and then, if I want to find AB, I enter the coordinates. The x's get matched together, 9 minus 2 The y's get matched together, 2 minus 2. So we have 9 minus 2 is 7, 7 squared. 2 minus 2 again is 0, so that's 0 squared. So then we end up with square root of 49, which is 7. So AB equals 7, as you can see. Alright, so we know 2 of the sides of the triangle. Now we can find the third side, BC. So I enter coordinates again. Alright, here I have the x's, the 2 and the 9 here. And then I have the y's, the 10 and the 2. So 2 minus 9 is negative 7. And 10 minus 2 is 8. Now this brings me to this another common mistake I'm seeing. A lot of people, when you do get a negative value inside one of the parenthesis groups, a lot of you are getting, for instance on this one, negative 49. It is not negative 49. All of you know negative 7 times negative 7 is positive 49. You should never get a negative value here or here. They're always going to be positive because of the squaring. And your calculator is not intelligent enough to see that, so you have to be more intelligent than your calculator. The only way you can get your calculator to give you a positive result here is if you put the parentheses around the negative numbers and then square it. If you write it just as it is here, or enter it just as it is here in your calculator, then it understands. You mean negative 7 times negative 7. Otherwise, your calculator, if you just do this, your calculator thinks you mean square 7 and then take the opposite of it. That's why some of you have been getting negative values here. Don't do that. Okay, negative times a negative is a positive. You should always get positives here and here because of the squaring. Alright, then simplifying. Square root of 113 and BC equals 10.6. Now perhaps some of you noticed that this is a right triangle, and this brings us to another one of our proficiencies, the Pythagorean theorem. This Pythagorean distance formula that we've been using up here is based on the Pythagorean theorem. But you don't always have a picture here like this to help you. Some of you probably, when I was figuring AC and AB out, said, well, that's kind of silly, Mr. Vanguard. Why don't you just count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. You can see that if the line is vertical in the coordinate plane or horizontal, you can just count the number of spaces and get the same result. So what happens if I do this? If I call this one side A, this one side B, and the hypotenuse, of course, is C. 8 squared plus 7 squared equals C squared. 64 plus 49 equals C squared. 113 equals C squared. Where have I seen that before? Didn't that happen down here? Right. So you see, it's based on the Pythagorean theorem, and the value of this Pythagorean distance formula is frequently you're not going to be given a picture like this. You're only going to be given 2 sets of ordered pairs. That's what happens in the proficiency, right? And you're asked to find the distance for them. So that's why you have to know this Pythagorean distance formula, unless you want to carry a piece of graph paper with you everywhere and graph points. But even then, you're probably only going to be given 2 of the 3 points. So that's why you need to know the Pythagorean distance formula. Alright, so that's how it works. You would get the same answer here as we got down here. Now you try it. Here is a pair of ordered pairs, the Pythagorean distance formula. Now you find the distance to the nearest tenth this time. Now on the proficiencies, you're finding this one to the nearest tenth, right? So be careful on your rounding, because some people have made a few mistakes on rounding. And you can do everything else right, but round it incorrectly, and you don't pass the proficiency. Alright, we're going to pause the video here and allow you to do this one and see if you can come up with the answer. Alright, we're back. And check your work against this. How'd you do? Alright, so we got 6 minus 2. Notice I put x1, x2 here. As I said, it does not matter as long as you match the x's, because you're either going to get the number 4 here or its opposite, -4, and when I square them I get the same value in the end. So that's why that part doesn't matter. Just match the x's together, match the y's together. Alright, so I have -4 squared plus 4 squared. -4 times -4 is 16, and 4 squared is 16, so I have the square root of 32. It's about 5.7. Alright, that's the main event of 4-1. There's some vocabulary in there related to graphing that you will see. There's quadrant numbers. Hopefully you remember quadrants in the upper right where the x and y coordinate are both positive. That's quadrant 1 right here. And then it goes counterclockwise around for quadrant 2, 3, and 4. You know this is the origin. You know the x coordinate, the y coordinate. You know how to graph. And you know that this is the x-axis and this is the y-axis. So that's just basic stuff that you're quite familiar with from previous instruction. And that is the main point of this lesson, and I think that will get you through it. Alright. So you have a geometric day and a geometric night, and let's get on with the class.